Welcome to Tech Talks. We are still together in biology and we are focusing on chemicals of life at large, but we are on enzymes, and our main focus in this is going to be the induced fit hypothesis. Remember, we discussed them earlier. These are mechanisms that are trying to explain how enzymes and substrates interact. We can also write it here and say, this tries to explain how the enzyme and the substrate interact to bring about catalysis. How do these interact to bring about catalysis? We talked about catalysis yesterday. It is all about lowering the activation energy such that the reaction can continue with minimum energy. So this induced fit hypothesis, for it says that as the substrate approaches the enzyme, the enzyme reconfigures to form a complementary shape where the substrate can fit. Where the substrate can fit. Let's finalize this statement. It means that it is a substrate that brings about changes in the enzyme such that the shape of the substrate can fit. So meaning that the active site of the enzyme is not permanent, but rather changed by the presence of a substrate in proximity or in touch. Once the substrate touches the enzyme, then the enzyme will add, just like how the amoeba does. When the amoeba gets into contact with a food particle, it readjusts itself such that it can engulf the food particle. So this has one note we can take. It does not explain the specificity of enzymes. Yet we agreed that all enzymes are specific in nature. So this hypothesis tries to tell us that amylase can work on proteins. So long as the proteins approach amylase, amylase will adjust to catalyze the hydrolysis of proteins. which isn't the case. So it has one query. It fails to explain the specificity of the enzymes. We can illustrate this hypothesis. So let's say this is our enzyme. That is the active site. We call this the allosteric site. And this is our substrate. That is our substrate. The substrate has a configuration far different from the active site of the enzyme. But when induced fit now is happening, the enzyme slowly can adjust to create an active site that is complementary to the substrate. So when this happens, we shall now call this one induction, causing induction. So this will continue further and give us an enzyme substrate now, complex, the mode of action, whether induced fit or is the same. So this will be our enzyme substrate complex, which will go further and give us back our enzyme plus products. So our enzyme remains unchanged at the end of the reaction, and then we get desired products. But we have said it has one shortfall, that it fails to explain the specificity of enzymes. And yet we know from proteins, enzymes, each enzyme takes up a specific shape. If it takes up a specific shape by the three-dimensional maintenance, an enzyme is supposed to be specific. So that's all what we can talk about enzymes. Other scenarios we can find in enzymes, we have discussed them. We have discussed effect of various factors on enzymatic controlled reactions. We have gone ahead to see how enzymes work and even the shape of the enzyme. So we can now move to another chemical of life in our subsequent lessons.